Hey you guys, 2011 question 6. This one here is what we call miscellaneous. Okay, sometimes you will get a random question, okay, that doesn't apply to the 6 FRQs. But that doesn't mean it's difficult. It's actually a little bit more straightforward. It's just that we have to go back and revisit some of the topics, okay? So here we have a piecewise function. Okay. And then in part A, they talk about continuity. Show that f is continuous. So by them stating that we already know that f is continuous at x equals 0, we just have to prove it. So here to revisit, remember with continuity, you have to show 3 different things. We have to show that the limit exists, the function is defined, and that pretty much the limit is equal to the defined function. Okay? So here we go, just so that we have space. We have to show that first the limit exists. So here, because we're trying to prove continuity at x equals 0, notice how at 0 is where the piecewise function breaks or goes in a different direction, okay? So we actually have to find the limit as x approaches 0 from the left. When you approach 0 from the left, you're actually focusing on the upper function here because of the fact that 1 minus 2 sine x is only for when x is less than 0, which is pretty much where we're approaching 0 from the left. If we're approaching 0 from the right, we're actually looking at all values greater than 0, which is the second function here. So if you haven't realized, I'm quarantined in the classroom right now. Yay. Okay, here we go. If I'm approaching 0 from the left, you guys are doing just this. You're plugging in 0. Remember when you guys are given a limit problem, the first thing you do is try to plug in the number and hope for the best. You hope for a value. And if there isn't a value, then we either have to apply manipulation or L'Hopital's rule, okay? In this case, if I plug in 0, the sign of 0 is just 0, so I'm left with 1, okay? If I'm finding the limit as x approaches 0 from the right, I'm looking at that e function. If I plug in 0 here, I also just get 1 because e to the 0 is just 1 there, okay? So I notice that they equal, so I'm going to state that the limit of f of x as x approaches 0 equals 1, okay? Now, to find f of 0, remember, f of 0 is an exact moment. The limit is when you get arbitrarily close but not exact. So if you look at your piecewise function, exactly at 0, you would have to look at the first function, not the second one, okay? So if I plug in 0 for x here, I end up getting 1. So I proved the first condition, the second condition, now the third one, the limit of f of x as x approaches 0. Does it equal f of 0? In this case, it does. So we actually don't need to put that question mark, okay? Therefore, f is continuous at x equals 0. Okay? Again, not that bad if you really think about it. It's just been so long since we've done continuity. But be ready for it. This could be the year that they bring it back. So keep that in mind, okay? Part B, here we go. For x not being 0, express f prime of x as a piecewise defined function. Find the value of x when f prime of x equals -3. Okay, so here we go. You guys have f of x. So let me get rid of all this notation here. F prime of x is just the derivative of each. So the derivative of 1 minus 2 sine x is really just -2 cosine x when x is less than or equal to 0. The derivative of e to -4x, that requires a chain rule. So the derivative of the outside of the same inside times derivative of the inside. I'll put that in the front. You should get negative 4e to negative 4x when x is greater than 0. Okay? We're trying to find out when when the derivative is equal to negative 3. So what we do is we set each function equal to negative 3. Okay? So this does require some analysis, but let me show you guys some things that you could pick up. So you're pretty much solving for x each, okay? Here on the left side, I'm going to go ahead and divide both sides by negative 2. So cosine of x is going to equal about 1.5. You could leave it as 3 over 2, okay? This one here, if you had a calculator, you could just use cosine inverse. But here they want you to analyze it. So really think about the cosine graph, okay? Cosine starts at 1 and it keeps waving, right? But if you guys notice, the highest and lowest it'll ever go is 1 and negative 1. So to answer this question, when will cosine come out to 1.5? Never, okay? Does not exist or undefined. So really there is no x value here, but there may be one right here for the second equation. I'm going to go ahead and divide by negative 4 on both sides. E to the negative 4x will equal positive 3 over 4. You could leave it as negative 3 over negative 4 if you want to. To get rid of e, I'm going to natural log both sides. So that'll give me now negative 4x is equal to the natural log of 3 over 4. And to get x by itself, we just divide by negative 4. So x equals the natural log of 3 over 4 all over negative 4. Don't even simplify that. Just leave that there. So there you go. We found the x value where the derivative comes out to negative 3. And notice how it matches up for the scoring guideline as well. Okay? Pretty straightforward. A lot of analytical, not too much graphical or numerical there. Okay? Last one here, part C. Here's something that we're familiar with, finding the average value from negative 1 to 1. So we know there has to be a fraction and an integral involved, okay? So we're actually going to integrate. First of all, the average is going to be 1 over b minus a. So here it's going to come out to 1 over 2. What makes this a little bit more challenging is because when you're traveling from negative 1 to 1, you will eventually pass 0. And 0 is actually the defining moment when your function changes. So we actually have to create two different functions here. So here we go. So we actually have to, now what we're going to do here is we're just going to figure out the value and then we'll take the average of it later, okay? So going from negative 1 to 1, we actually have to split this from negative 1 to 0 and then from 0 to 1. So if you're traveling from negative 1 to 0, you're actually only dealing with the 1 minus 2 sine x function. If you're traveling from 0 to 1, you're actually only dealing with the exponential function. Okay? The rest here is just integration. A lot of busy work again, okay? The integral of 1 is just x. The integral of sine is negative cosine. So that comes out to plus 2 cosine x. And we're going to evaluate that from negative 1 to 0. The integral here, again, there is a function inside of another function. So mental use substitution. I'll do this on the side here. The derivative of everything in red will be negative 4. The reciprocal would be negative 1 over 4. And then you just integrate. Integrating e is just itself, which is what we have right here. And here we integrate from 0 to 1. So they simplified it. Here's what I would do. I would plug in upper, so 0 plus 2 cosine 0. minus negative 1 plus 2 cosine of negative 1. Okay. Plus, and then here I have negative 1/4 e to the negative 4 times 1 minus negative 1/4 times e to the negative 4 times 0. That right there is your integral, but not your average. So to make it your average, you put a parentheses around this whole thing and you squeeze in a 1/2. Leave that sucker there. It's their fault that they gave you a complicated problem, so you make them work for it, okay? Equal is equal. And there you have it.